Well, good morning and welcome. So you are in the right space, I hope. This is JSON shouldn't remind you of Friday the 13th. So we're hoping that you are not terrified in being here. You might be. I've noticed a lot of you are hiding in the back. I promise you, I don't have a chainsaw. They wouldn't let me through the security with it. So I'm Bridget Cogley. I'm a Tableau Zen Master. And then I also work for Technion Data Solutions.
Hello, everyone. My name is Patrick McCormick, and I'm a Tableau ambassador from Wisconsin, and I have my own boutique analytics firm.
You got to do your mic.
My mic. Good one. Okay, there we go. Morning, everyone. My name is Patrick McCormick. I'm from Wisconsin. I'm a Tableau ambassador, and I have my own boutique analytics firm. And for those of you at the keynote this morning, I fall in the introverted camp.
Team introvert.
When you go home, if you're interested in an applied use case of what we're going to be talking about today, you might want to check out this session on YouTube, Truth Be Told, about Delta Dental of Washington, so insurance use case applying speech analytics.
Also warn you, this is a PG-13 rated session, so there will be no swearing, there will be no nudity, there may be chainsaw effects, and yes, there will be lots of scary JSON code. We also hope that you have a mature understanding of a number of terms that we're going to throw at you. We're probably not going to clarify things, so if you're hoping for us to explain JSON or really go into a deep dive of how JSON itself works, we're going to showcase an example, but we're not going to delve deeply into the basics. And then also, just so you know, this talk is structured very much like JSON, so it's highly unstructured. So just be aware you're going to get multiple threads. At some point, it will all come together because we're going to showcase techniques to bring it together. So that's the whole point of this talk. So naturally, we had to kind of do this nice diverging track. So lots of branches. I promise you, at the end, this will come together.
All right, here's our agenda for today. Who has seen a Friday the 13th movie? I was kind of wondering, that's a pretty good showing. So you know it was set in Camp Crystal Lake. So we're going to get started off this morning with why JSON is so scary to us. And then Bridget's going to tell us a little bit about our use case and how we came up with this solution. But this solution is not about our use case. It's about consuming JSON data in Tableau as well as integrating it within your enterprise data warehouse environment. Then we'll take a closer look at getting to know JSON. We'll take a look at our sample JSON data and the structure and some of the complexities in dealing with it. And next up will be Bridget with the key part where things will come all back together. JSON meets Tableau. And if you missed Bridget at the keynote, Devs on Stage keynote, she's a dancer.
There will be dancing. I apologize.
And then we'll wrap it up with some alternative solutions. So why is JSON so scary? You're not sure what's under the mask. He looks kind of pretty rough and intimidating. It's kind of like when you crack open a JSON document for the first time. You're not quite sure what's in there. It looks pretty rough and intimidating if you're used to looking at nice, neat tabular data. JSON specifically is semi-structured, so it is not tabular, as where our good friend is. It is has potentially complex data relationships. So think of any database that you've worked with. It can be simple, it can be complex, same deal with JSON. It also lacks a standard interface like SQL. And at the end of the day, JSON is just a text document, so there's no inherent performance tuning options. When it comes to Tableau, it's still a little bit scary. Tableau can, as you know, pull in JSON documents, not prep yet, so you can't connect to JSON data from Tableau prep. Tableau Desktop, you can connect to JSON files, but to deal with enterprise complexity and scale, isn't quite there, and there's no modeling capability directly in the tool to make sense of a potentially complicated JSON structure. This is the dialog that some of you may have experienced in Tableau desktop when you open up a JSON document. So it's great if you're cherry picking like one level of detail or maybe 2 levels of detail. But if you've got a more complicated JSON document, it doesn't necessarily fit the bill.
So our session came in part from a client. So there's a company called VoiceBase. They've sponsored a number of things here. They've got a great large booth. How many people here are doing call center analytics? Anybody? Anybody working with speech or maybe NLP in any way, shape, or form?
Got a taker?
Okay. All right, perfect. We've got some takers. Part of what VoiceBase does is it makes voice visible. It helps bring light to what's happening in a spoken conversation or a chatbot or any other type of kind of communication. And so that's what they do. Their typical use is a call center. And so they are taking these kind of conversations, transcripting them out to JSON files. Could you just for 1 second take a moment and think how you would organize a conversation when you get down to word, when you get down to sentiment, when you get down to the communication I'm doing right now, which is nicely transcripted, go Tableau. How do you then take that information and analyze it in a relational format? It's kind of hard. It's kind of hard to get down to that word level in a relational standpoint. You end up with lots of duplicate if you think about this in a relational standpoint. So we're working with JSON documents and trying to understand what customers are saying. And so we're taking a lot of volume of text and trying to capture it. There's a few ways we do this, and our client has come up with one way, which is VBQL. It's a little bit like SQL. It's a little bit like regex. It's an awesome superhero that comes in and helps categorize some of the speech act. And so we're able to begin to understand what's being spoken. Now you're here for JSON. You want to begin to understand what's really important to you, and that is the structure of this. What in the world does this look like? When I'm talking about unstructured data, what kind of levels and grains am I bringing in? So for example, I'll start with the call, and my client provides me metadata. They're providing me information about the call. I'm also, through the VoiceBase engine, getting a number of metric values. I'm getting things like sentiment. I'm getting various counts and scoring and words per minute and everything else that I want to know as an analyst. But then below that, we've got our categories that we created using VBQL. We've got category matches and metrics with that. We've also got conversations. So each turn we can capture. We can capture speakers. We can capture noun-verb pairs. We've got so much more, too. I'm not going to focus on the part in the blue. You're going to see these green colors, pink colors, and orange colors. And again, for anybody that's colorblind, I promise you I have accommodations coming soon. So when we think about these items, you're getting at the call level things like media ID. This helps us identify unique calls. Extraordinarily important as I start enriching this data with lower grains. I'm also pulling in my repeat callers. I'm capturing if a caller at a call center is called in twice. Those are the calls I probably want to look at because they're probably hot and angry. So I want to make sure that I'm finding those people and making sure people aren't frustrated. It's one of the primary use cases of something like speech analytics is trying to ensure our customers are satisfied. The other thing I'm looking at are things like sentiment, where I'm beginning to understand how do people feel? How does that change over time throughout the conversation? With categories, I'm capturing a number of different things, such as why are people calling? What are they calling about? In our example, you're going to see those call drivers or intents, but you're also going to see airlines mentioned. We've got things like emotions and so forth. I'm also going to capture what words triggered that flag. And then I'm also going to look at the conversation. So again, because JSON likes to organize things in folders, you see I have this empty spot. This folder is just there. And then I'm also looking at speakers and callers. So who said this, the agent or the caller? And that way I can begin to understand, am I seeing that nice empathy and pattern matching I'm hoping to see? Or did my agent come off as way too happy and my caller is way too angry, and I'm not getting that empathy shown? So, and then I also get what's really important to me also as an analyst, and that's time stamping. Anyone here love timestamps? I do. That way I can actually see the change over time. It's row level. It gives me really deep, as close to that interaction as possible. Without further ado, I want to show you how this translates to a dashboard, because at the end of the day, we take our JSON and we need to make a product. We need to communicate this data and our findings. We've got the data, but it needs to be usable and reliable. And so you can see, we actually drew this dashboard out first. This was part of a product. We said, these are things people are asking us about. They want to see calls. They want to see sentiment. They want to understand what's going on with different dissatisfaction and satisfaction levels. They want to know where we're seeing the spikes in repeat callers. That gives me an idea that maybe my hold times are too long. Maybe people didn't get a first call resolution, which is a big deal in the call center world. I also want to understand why people are calling. Are they calling because they're frustrated, they can't get in? So my example is going to be an airline. I'm going to reference this multiple times with my airline. So did anybody here lose their luggage? Good. Oh, I'm so sorry. Okay, so you would be one of my customers calling in about lost luggage and saying, look, I need my luggage. I'm going to a conference and I need all these data shirts. Very important, cannot be without my data shirts. I can see those spikes over time. So I can actually see that people are flying in Monday and Tuesday, and I can see that spike in lost luggage, and I can start tracking that. I can also see which airport. So here we are in Las Vegas, LAS, by the way. I thought it was something different. I can also see the top words driving these. Again, this is something that we designed beforehand. For my colorblind folks, you'll notice that I've got certain things in line differently, so you can kind of track your calls versus your categories versus your noun-verb pairing. Again, this is multiple levels, which again, very hard to relate in a non-relational format. Without further ado.
All right, so let's get to know JSON a little bit. Maybe he's not such a bad guy after all. So we're going to present really kind of two secret sauces today. So the first secret sauce is preparing that JSON data for consumption in Tableau. The second secret sauce is how Bridget consumes that data in Tableau for a rich analytic experience. So here's our simplified solution. We've got our JSON documents of all different sizes. And in our use case, we're landing those JSON documents in Snowflake, a cloud data warehouse platform, and leveraging its capabilities to handle semi-structured data to build views that parse that data out of the JSON documents into our friendly tabular data that we can consume in Tableau. And likewise, consume in Tableau, and then you've got it in that familiar format, then it's just potentially another data source for integration into your data warehouse environment with all the friendly issues related to that in terms of change, data capture, and business key integrations, and all of those good things. All right, so we're going to take a closer look at what we did in Snowflake. This is a Tableau conference, not a Snowflake conference, so we won't dwell on it too much, but we do want to show you the moving parts to illustrate what's involved. So we'll take a look at a JSON table and see where that data lands in a variant data type column. We'll see that we can pull out that raw JSON that we landed in there, and then we'll query that JSON document and pull out specific attribution at different levels of detail. We'll also create some views in the data model that Bridget just walked us through so that you can see the different levels of granularity being pulled out. And then also of note is once we land this data in that database platform, then we have performance tuning capabilities of that platform. So we can create materialized views, or we could use ETL to pull that data into other optimized physical table structures. All right, so this is an excerpt of a JSON document from what Bridget was describing before. So up top, you can see our friendly media ID, which is a GUID surrogate key to the call transcription. And then you can see attribution at that same level of detail, the account name of the source and the length of the call. And from there, we can drill down into categories, and we can see that we have category matches where we've got a start and end timestamp within the transcript and the exact text that triggered that match for that category. The details of that category definition, as you recall from the earlier slide, is defined in the VBQL. And then down at the bottom, we can see the category name, and the category value represents whether we got a hit on that category or not. So up top, you can see we've got a category called live chat greeting. We did not get a hit, but on the marketing brand mention Thrive Air category, you can see in the exact match in the excerpt from the transcript where we did get a match on that. Okay, from here we're going to live on the edge a little bit and pop out to Snowflake. All right, so this is what Snowflake looks like if you're not familiar with it. So first up, we'll do a describe on that table where the JSON data lands. Oh, gotta pause the PowerPoint. There we go. Thanks, Bridget. All right, so getting the JSON data into Snowflake, so it lands in a physical table that just has one column on it, at least in our example. That column has a special data type of variant, which enables the semi-structured capabilities of the Snowflake platform. Now again, without going into too much detail here, there's different ways you can stream your JSON documents into that physical table. You can land them in an S3 bucket and copy them into that physical table with Snowflake. Lots of different options there. So let's go ahead and take a look at that table and pull 3 rows off of it. And here we can see the JSON body. And there we go. And here's where we can access all of the JSON data in that row of that variant column. And we'll just copy that out of there and pop over to Notepad++ and paste it in there. And voila. Now we can see the complete source JSON document unchanged. So that's representing the enriched transcription of one particular call. And from there, we can start to pull out the attribution. So this is the green boxes in Bridget's data model diagram. So we're talking about call level of detail. Like when we were looking at that excerpt of the JSON data, we had account name and media ID and the length of the entire call. And so this is the syntax that Snowflake provides us. And so the name of the column is JSON, and then the rest is dot notation through the JSON hierarchy. So in this case, we're going to body and then media ID and then typecasting it as a string. And you can see likewise down here when we get to the call length, that's represented actually in milliseconds, and that's an integer. So we can go ahead and create a view based on that. And then we can take a look at that view. And so I'm pulling off the rows for that particular media ID. So that sample call that we looked at in the excerpt of the JSON data had a particular media ID as representing one call. So that's what we're looking at here. And you can see that there is that one row at that same level of detail. So starting to not look so scary after all. But we got to pull the mask back a little bit farther and look at the categories. So this is where it gets a little bit more involved because that's a lower level of detail, right? But Snowflake has this semi-structured capability that enables us to flatten that lower level of detail out. And we can also bring in the higher level attribution. Specifically for integration purposes, we want to pull in that media ID, the GUID that identifies that call. So that's going to enable us later on to integrate this data back together in a way that suits our purposes. So likewise, we can give this a run and create that view and take a look at that same call for that category that we saw that had a match, right? And there's our data that's not looking so scary at all. All right, and then we've got two views created now, right, at this 2 different levels of detail. So this should start to be familiar territory for you. And then we can join those 2 views back together based on media ID and see the results down below. And then we're getting back into familiar territory and also levels of detail that we're familiar with handling. All right. Meanwhile, back at the ranch, prepped JSON meets Tableau.
So we've put it into Snowflake, and what does this look like as an analyst? And so what's happening for me is I'm calling the data relational-ish. If I join it together completely, I'm going to potentially end up with a nice Cartesian effect. Anybody here love Cartesians? Excellent answer. A couple people do like Cartesians. They kind of make gremlins of data, and so sometimes we're pulling in millions of calls, and we are pulling in also within those calls millions of words. So I've got a number of different grains, and so this thing can get out of hand quite quickly. And so we want to be very, very strategic about how we handle this. And so I've highlighted 2 particular columns I want to look at. So I've got call driver, and these are things like lost luggage. These are things like a wheelchair was broken. So when we've gone to the airport and either a wheelchair was broken by a wheelchair user or somebody needed a wheelchair and it was broken. But then I want to be able to relate this. Did we find that luggage? Did we fix the wheelchair problem? And if you notice, I've got 1 column of data. So that's a very hard question to answer right now as it is structured today. So we might try to play parameters. We might try to make this really unfun click-down experience. Does anybody like that kind of click-down experience? I don't. And does that really make it easy to do high-level reporting? Does it make it easy for the end user to feel like this data is integrated, or does it make my data feel like a barrier? So what we've had to do is really get very strategic about how we handle this, because we want answers. We need to know if these problems were solved. We need to know if empathy was shown, or if we found the luggage. And so what I have approached this with is a different novel technique. And so the first one, I'm going to teach you guys to dance if you don't mind. And so the first one is we're going to stair-step it out. Oh yes, we're doing this. And what I mean by stair-step it out is I'm taking all of my meaningful data and I'm pulling it out into separate columns. So that way I can begin to see this as separate data. So you can see my natural stair-step. I've got lost luggage. I've got first call resolution. Now they're still not together. They're still not in tidy, tidy rows. So I've stair-stepped it out. I can kind of start seeing maybe where this is going. And so the next part is I'm going to create a set. I'm going to start joining these items together. And so I'm going to pick one. I'm going to say, okay, for my call drivers, I'm going to make a set. This is going to make sense, I promise. Everyone's starting to look a little panicked. I'm going to start by making a set. Now, Tableau did this really, really nifty thing a few versions ago and created set actions. These become important. These become incredibly important to me because they, A, allow my users to multi-select. So if people want to click on or highlight multiple things, they can. Are you starting to see maybe where this is going? Now, I don't want to literally filter on the set. No, 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 it's not that easy, folks. So stair-step, set, there's more to this dance. So what I'm going to do next is I'm going to create a level of detail calculation. And what I'm going to do is say, fixed for each media ID, is this thing true? And that's what I want to know. And so I'm actually saying, is this media ID in this set? And so if I've selected the set, I'm going to start getting somewhere with this fixed level of detail. The nice part is once I've done that level of detail, it's going to carry through all my columns, and now I'm going to use that level of detail to filter. So we've now done our 4-step dance move, and anywhere I need that filter, I'm going to put it on the chart. So without further ado, let's see this. What does this actually look like? And again, this is a real live demo, so we are potentially at risk of all sorts of things happening. So here's my dashboard today. It's great as is. I can click on things and begin to filter, and it starts to feel very integrated, right? I'm able to see that if I've had 20 calls on certain places, I can kind of get a feel for where that falls in. I can see that, say, wheelchair falls in with special accommodations. Now, if I click on airport, that doesn't work yet. Let's go ahead and take a look. So I've got my call drivers filter on this, but as I look through, I don't have an airports filter. So I'm going to go ahead and I'm just going to create a set. And you can see I've got San Fran selected. I'm going to call this airport. Click OK, and so now you can see I've got an airport set. I'm going to come up here to my call drivers filter, duplicate this, and I'm going to edit it. And once I edit this, instead of it being the call drivers filter set, this is going to be airport. So again, this is the one challenge of live demos. They always say, do not ever do live typing. So now what I've done is at each media ID, if the set is true, then it's going to give me a 1. If the set is false, it's going to give me a 0. So I'm just going to put that out there. And so now I've still got it renamed wrong. I'm going to actually rename that as well so I can find it. And then I'm going to go to a different sheet. I do not want to put this filter on this sheet, but you see now I've got the level of detail, and when I look at it, I've got an idea of certain media IDs falling into that category and certain ones not. I'm going to go into call drivers. I'm going to take that filter. I'm not going to select here. Instead, I'm actually going to say use all. I'm going to come here, and I'm going to do it by condition, because what I want is the maximum value of the set filter. So a couple things here is if I do a fixed level of detail calculation and I don't specify anything, it does it for the entire data source. So that's a nice little tip to take with you as well. Whoops. And we are at live demo, so I'm going to go ahead and just cancel out of this. And so what I'll do again is, so while we're waiting for this to cancel, hang on. Nope. All right, we're going to go back into our PowerPoint. So then you can see where I would actually set my filter. And a key part of this is making sure that I've got max call drivers filter and then setting that equal to the call drivers filter. So I've got a fixed level of detail. So I'm finding out for this entire data source, is there a 1 at all? Do I have a set selected? And then if I don't, it's going to show me that value. So that way it pulls out the individuals that fall in that set category. And that allows me to put this along the dashboard and make it feel like an integrated product. And there we go. And so that way you can see that calculation. It's very nice. It makes it just feel a lot more integrated. So this is kind of a cheater way to stair-step, level of detail, and set it. So again, we're taking relational-ish data, we're doing the stair-step, we're making sets, we're doing level of detail and filtering, and that makes this feel like an integrated product. This is also a technique I've used on non-JSON data, where I've just had different data I've wanted to pull in and not had it be at the same level. So rather than create Cartesians, you can actually union your data based on groups and use the same technique. And it's actually very effective. I get a lot of questions about your using level of detail. How does this perform at scale? You would be surprised. I know I was.
Awesome. So if you don't have this exact technology stack with Snowflake, there are other ways you can get the job done. So there are other database platforms that can perform a similar function, such as Postgres and SQL Server and others. Another alternative solution is to leverage your data preparation or ETL tool. Some of those can have various levels of capabilities in parsing JSON data, so you can let that process parse the JSON data into target tables, much like we're creating views in our solution.
And so the final part of this is that JSON can be your friend. It can actually be a really valuable and insightful data source. Oftentimes I feel like when we get this schema type data, you struggle to make it very usable. And instead what I've found is using this type of technique makes it far more accessible. It makes it feel integrated. You allow your audience to feel like this is integrated. It's a little bit more of work for you. You do have to kind of keep in mind the filters that you set, but it really makes it cohesive. So it is an odd way to approach it. Anybody that's very familiar with data warehousing may feel like this is a very wrong way to do things. But sometimes you have to do things wrong to get it right. And so that's kind of the idea I want to leave you with today. Now, we're going to go ahead and open it up for questions. I know my demo kind of failed, so if we want to go back into that workbook, it may take a few seconds. Questions? We've got a question in back.
I'm sorry, could you repeat?
So the question is if there's a data connector in Tableau. I have seen people circumvent the lack of JSON accessibility. There is the web data connector. I can't remember who did it, but there is a web data connector out there originally for parsing out JSON. I've also seen people pull the JSON into Tableau, export it, pull it into prep, and start doing very creative things. Now, I believe, did I see in the keynote anything about JSON? I don't know, but
No JSON noodle yet.
there you go. Got a question in the back, go ahead.
Yeah, for performance tuning purposes in Tableau, we did basically a change data capture, so the parsing happens once up front as the data is loaded into the database, and then we take that data and put it in a more optimal physical structure for consumption in Tableau. Well, I mean, basically start out with the dynamic approach and then adjust as needed based on your requirements.
You got another question? Go ahead.
So we use JSON to store translation, so basically internationalization. So our JSON structure is pretty simple. It's like English, French, Spanish, whatever, right? One approach we've been thinking about, as opposed to doing what you guys suggested, which is extracting data into tables, extra rows in the database, which kind of explodes our data along the language dimension, which is not useful, is thinking about using regular expressions inside of Tableau to do calculation. So create a calculated field where I can use a regex to pull out, the translation. We're kind of in the early stages of that. Have you seen that, if that's a good performance?
I would be concerned about the performance. I would be, especially when you're doing anything where it's having to look row by row, when you've got a lot of row by row calculations. It definitely gets intensive. One of the nice things about sets is that it's actually doing an aggregated calculation.
Okay.
So maybe you could do it, apply regex in the database in a similar way that we're creating views. So land the JSON document and then process it from there.
Well, the challenge we're having is that we end up duplicating so many rows just because of language translations. And then that gives us performance problems on the other side, which is we have,
Yeah.
you know, too
Could
many
you-
rows.
could
We're
you-
processing, you know, 10 times more rows just for what they all have the same data in them, except for our label.
Well, so one nice part about this step is so the data that's similar, you can actually say this is the master level data, and then here's your English level data, here's your Spanish level data, here's your French level data. So that's part of what we're doing with the calls, where we've got all the call data at one grain, and then everything else is almost unioned under it as well. And I've done that as a technique and then used this to where you've got your source of truth with the metrics, and then when you need those other pieces, you can kind of pull those in using the sets filter. But that's where that kind of technique of you stair-step it out, you do your sets, and then you do that level of detail and then filter on that. That helps kind of make it feel like a unified experience. You're referencing a non-Cartesian measure set.
So without something like Snowflake that does the schema on whatever, for something like Postgres, we would be pre-processing all the data to take those fields and put them in separate tables, and then build the sets from that information.
So one thing you would end up doing is potentially unioning. And so when I do these unions, I make sure to label them. So it's like this item is this item is this item is this, and that helps kind of build out that logic. It's definitely a practice in logic and how to do this. It's an extraordinarily hacky solution, but it's one that's been very, very effective. I've actually used it multiple times when I've run into just complex data questions where I need the data set integrated. Blending doesn't work. Trying to do parameter filters is even too limiting. But what this does is it allows you to go ahead and add rows to Tableau, because Tableau likes rows. It really doesn't like a ton of columns, though. And especially if you're trying to analyze across a ton of columns, it really ends up being very, very limiting. Whereas when you add rows, it tends to be less limiting, at least in my experience.
Good questions.
Yeah.
Do you know how big a JSON document can be before Tableau just by itself gets pretty overwhelmed? Is it 100 times?
From my conversations with Tableau, they prefer you have 10 schemas or less with JSON. That's typically how they measure it, is schemas. And so they prefer 10 schemas or less. You saw with our VoiceBase example, 223. So some of that is we could definitely optimize the JSON document for Tableau use directly, but a larger part of that is just setting in that intermediary allows you to kind of play with how you want it structured. And so another intermediary is Alteryx. They've got a number of JSON parsing tools, and so that's one way I've also done it in the past as well, is I've pulled it in through Alteryx, worked through that as well, and massaged it.
Tried flattening our stuff.
It's hard. Yeah, no, it's extraordinarily hard to flatten JSON, so a part of this technique really came from how do I get insight? How do I get this integration that I'm seeking? And how do I make this invisible to my end user? Because I don't want my end user to feel the data barrier. And so this technique was really born of how do I make this barrier invisible to my customers? And it's one I've actually used multiple times, but particularly with this, it was extraordinarily effective. If there's no other questions, I will let you folks run and get coffee and possibly make it to your next session early to get a good seat. So thank you very much.